Okay, hello and welcome to video 6. We are finally getting on to our first, well, maybe you could argue second, but effectively our first big topic we're now covering in this video. This is going to be a hard topic, and effectively the way I'd like you to think about these videos is these videos contain all the tools you want to have ready at your disposal. You just want to make sure that you know everything that you can do, so that you have this in your toolbox. And then the accompanying example videos, where I just go through a bunch of questions, should only ever use stuff that are in these videos. And so the point of those videos is to show you how to apply these tools, but also, almost more importantly, how to know which one to use in order to get to the solution most quickly. So I want to start off by saying that modulus and inequalities is a nasty topic. It's probably the most advanced maths you get on the GMAT. And so in that sense, you need to know the most stuff potentially in order to actually have a good grasp on the topic. The main thing I want to say is that there's no one-size-fits-all method for these questions, and you just need to be sort of adaptable and have all these tools at your disposal. So we're going to be using a range of things from graphs, just normal algebra, number lines, and also just testing solutions. That's very important for this this topic area and the GMAT in general. So just bear that all in mind and make sure you know every single tool from this video. So the first thing I want to cover is the idea of when you have simple modulus things. First of all, what is a modulus? It's useful to just think of it as the length of a number, or distance from zero. Now, that on its own isn't necessarily going to allow you to answer questions, but it's just useful to keep in the back of your mind. And in general, what that means is, because obviously, distance from zero can go two ways, positive or negative. Modulus questions tend to be more often than not have two solutions or more, just because of you can have two different distances depending on which way you go. So that's sort of the thing to think about when we talk about what is a modulus. That's all it means. But then we actually need some concrete ways of dealing with it. So the first thing I want to talk about is simple modulus questions. And my definition of simple is that you've got no double moduluses, moduli, something like that, and no constants. So for example, simple would be mod x minus 3 equals mod 2x plus 5. We haven't got any double modulus on one side, and we don't have any constants. Not simple would be, and this, you'd be surprised how much harder this makes this, the moment I add a plus 3 there, or the moment I add another modulus. So effectively, what you want to do in any modulus question, if you can at first, you're not always going to be able to do this, but if you can, just get one modulus and no constants on each side. So for example, if I just say that this question was given to us like this, solve this, well, that's not simple yet because there's two moduluses on one side, but we can make it simple by obviously bringing one over to the other side. And so that's the first thing you want to try and do if you can. Make modulus questions simple like that. And the reason why we want to do that is because the moment you have something in a simple form for moduluses, all you do is you get rid of the modulus, and then you say equals plus or minus the other side, all in brackets. And then we're just going to solve. So the plus one, x minus 3, equals 2x plus 5. So that tells us that I believe minus 8 equals x. And then the alternative answer, the second answer, x minus 3 equals minus 2x plus 5. And that's just going to give us be careful, minus 2x minus 5. So that's going to give us 3x equals minus 2. And so x equals minus 2 over 3. Okay. And so that's how to deal with simple moduluses. Same thing applies if, for example, I don't have a modulus on this side, let's say that was just 2x plus 5, well, I can still just say x minus 3 equals plus or minus 2x plus 5. So it doesn't matter whether you've got moduluses on both sides or just one. You just want to get rid of the modulus and do plus or minus on both sides. So that's the simple type. Hopefully that all makes sense. Now, then, of course, we immediately get onto the idea of harder modulus questions. And so the first thing I want to say about these is these questions are actually objectively quite hard. And so what often happens in the GMAT is I'm going to show you a bunch of ways in theory of solving these harder questions, you know, the proper way. But the GMAT often doesn't expect you to do that. They often want you to just test numbers out. So, for example, find the minimum value of x plus 3 plus x minus 3 plus x plus 5. Okay, so that's actually going to be very hard to do properly algebraically or anything like that. So all I'm going to do is say you should test some numbers. And with moduluses, when's the minimum likely to occur? Well, it's going to be when one of them is 0, because otherwise you're sort of just wasting, you know, if not, the least they can be is 0. So if one of them is 0, that's sort of the best you can do. And so there's very few numbers to test here. We're just going to test when x equals minus 3, when x equals 3, and when x equals minus 5. And so let's just see what the values are for each of those. So for minus 3, we get 0 plus 6 plus 2. For x equals 3, we get 6 plus 8. And for x equals minus 5, we get 2 plus 8. And so apparently x equals minus 3 is 1. So nothing more sort of scientific than that. Yeah. That's sort of one thing. And then, you know, the other type of test is find the value of x that solves, and then they can give you something as nasty as they want. You know, who cares how hard it is? Because if they say find the value of x that solves, well, that's incredibly difficult, except for the fact that the GMAT is multiple choice. So just sub in the answers and find out which one works. And that's something you can do in general for equations. If they want you to, if you're trying to solve an equation, just test answers because they've given you, you know, the answers there. So that's just something to keep in mind in these questions in particular. Just and to be honest, a lot of topic questions, just you need to use the answers to help you, because and on the very hardest questions, that's not going to work, and you're going to need these other tools. But just bear in mind, you know, you always want to be keeping an eye out for cheap methods. So make sure you try that whenever you can. Okay, so I already covered this partially in the last video about graphs. So, for example, if we need to solve, let's say, solve this. Let's say, how many integer solutions are there to x plus 3 minus mod x plus 5 is less than 7. Something like that. Now, in my opinion, there's not many very easy ways of solving this quickly. I suppose you could test it. You could sort of start testing out values, but that's probably quite an easy way to go wrong. So what I'd say is just the moment you've got something like this, I'd start thinking, okay, well, I want to simplify it as much as I can, and having two moduluses on one side is not the most simple thing I can have. So why don't I just rewrite this as this: x plus 5 is less than mod x plus 5 plus 7. Okay, and so that's rewritten. That's the same thing. And so now we can just sketch both sides. Sketch that side and sketch that side. And if you've been practicing graphs, as I requested, that shouldn't be very hard for you. So we've got -3 for one of them, gradient 1. And then -5 for the other. So he's over here. Oops, but he's also at +7. So he's all the way up here. I really should have done some more room, but he's going to be sort of parallel to that and like that. So effectively, how many integer solutions are there to that thing is less than 7? Well, the answer is infinite, because our blue line is always above our purple line. So that's one example. But then let's say you know, we got a slightly trickier one. So let's say x plus 3, mod x plus 3 is less than, now let's say mod 2x plus 3 is less than mod x minus 3 plus 2. Okay, so same idea. I personally think that's very hard to solve sort of officially, but we can just sort of sketch it out to get an idea. 2x plus 3 on the left, so that's -3/2 is where it sort of meets this thing. And then it's going to have a gradient 2, and it's very important to sort of keep how steep they are in mind. So your drawings have to be relatively good. And then the other one is at 3 and +2. So he's going to be somewhere here, and he's going to be a lot shallower. So he's going to be sort of that way, and gradient 1, so something like that. Okay, and so now we want to ask, okay, now we've sketched that out, how is that helpful? Well, now what we need to do is say how many integer solutions are there to that. Well, we can sort of get an idea, because we can see that, and I probably should have sketched it a bit better, because I believe this actually crosses the axis at 3, and this crosses it at 5. So I should have sketched it a bit better. But the point being that I'm sort of, you know, one of the answers is going to be, it's going to be relatively obvious from the answer choices which one the answer is. And let's say we don't feel comfortable knowing choosing the answer from that. Well, we can just sort of, we can take a look at our sketch and say, okay, well, what do we, if we actually need to solve this thing? But again, I'm sort of hoping, you know, if you've drawn a good sketch, you shouldn't really need to. But we can say, okay, well, how many integer solutions are there? Well, that depends what this is and what this is. So how do we do that? Well, we know that using our sketch, if I call this A1, we know that at A1, we've got that the purple line is in its positive side. So we've got 2x plus 3 is equal to, and the blue line is on its negative side. So we can flip that sign. So that's 3 minus x plus 2, just because sort of, just to make sure you understand that this is its negative sort of line, whereas this is its positive line. So I've just flipped, that tells me which one, whether we're flipping the modulus or not. So that just tells me that 3x equals 2, so x equals 2 over 3. And then for the other one, a2, we know that they're both on the negative side. So minus 2x minus 3 equals minus x plus 3. And so I believe minus 5 equals, no, minus 8 equals x. Okay, and so then we've got the answer, because we know that the solutions are at 2 over 3 and minus 8. So how many integer solutions are there? Well, there's 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, not minus 8, because they're equal there. So the answer is 8 solutions, I believe. So these questions are sort of, much harder, but you can sort of see how using graphs, you can definitely start to get an idea of what the answer will be. And again, for the imagine it was instead of how many integer solutions, which is quite a nasty thing, if it was just find the values for x for which this is true. Well, as soon as you sketch the graph, then only one of the inequalities is going to be look about right. You know it's something like well, obviously we've solved it, but you're looking for something like roughly 1 is less than x is less than minus 10, something like that. Obviously it was 2/3 and minus 8, but the point being that it's going to be pretty obvious based on the size of your answers. So hopefully it's clear why sketching is helpful, and you'll see a lot more in the example questions. But one thing to just draw attention to is do make sure that your sketches are actually quite good. You want to make sure your gradients are about right and your scales are about right. That wasn't particularly good, and you saw it made it a little trickier. Okay, and so then we get on to sort of inequality rules for modulus. And in general, for the harder moduluses to do with inequalities, no different. The advice is no different. It's just going to be sketch the graphs. Make each side roughly as difficult as each other. For example, here, x plus 3 minus mod x plus 3 minus mod x plus 5 is less than 7. Well, the left-hand side is much harder to sketch than 7. So I want to bring one of them over so they're both roughly equally difficult to sketch. Then to sketch it out and just ask yourself, well, when is one line below the other? Very, very simple. So that's what you do with harder modulus inequality questions. What you can do on the simpler ones is, let's say we've got mod, I don't know, x plus 3 is less than 7. Well, effectively, what you do, it's very similar to solving the equals. You can just get rid of the modulus, and you need a plus or minus, but you just need to be very aware of what happens to the rules. So it's x plus 3 is less than 7, and /or x plus 3 is greater than minus 7. So make sure you flip the inequality for the minus version. Similarly, if we have x plus 3 is greater than 9, then we've got x plus 3 is greater than 9, and x plus 3 is less than minus 9. So that's what you want to do for inequalities, simple inequalities with modulus. But again, anything harder, just use graphs, which, to be honest, I've already covered here. So we can sort of tick that off. Okay, now moving more into sort of the some pure inequalities section. If you've just got a product, and they often do this, an algebraic product, x squared minus 4 over x plus 3 is greater than 0, and they want to know, how many integer values solve this, or much more commonly, maybe xy xyz greater than 0 ? So for any inequality, if it's asking is the product greater than 0 or less than 0, well, there you don't actually really care about the size of the numbers. You only care if they're positive or negative. So the way you'd sort of go through them is you have to all you're asking about is what is the sign, what are the possible signs of x or x, y, and z in this case. So plus would work, but also plus minus minus, and sort of, you need two minuses to cancel out and stuff like that. Similarly, on the left here, I could rewrite this as x plus 2, x minus 2, using that difference of two squares thing from earlier, because if it comes up, it's almost always correct to do that. It's greater than 0. And so, well, when does that work? Well, I need to pay attention to whether these things are, if I have them all plus, that works. Well, when do I have them all plus? I'd say as long as x is greater than 2, they'll all be plus. And then sort of work my way down through the lower numbers and sort of see what happens. So below x equals 2, this guy becomes minus. So now all of a sudden this inequality doesn't hold. So I need to go all the way down until the next one becomes minus, which will be below x equals 0. And then, so that will work for a while. So for x equals minus 1 will work, but then x equals minus 2, well, all of a sudden this guy's no longer plus, he's 0, so that's not going to work. And at x equals minus 3, the thing on the bottom's not working either, but then below x equals minus 3, that's minus and that's minus. So again, it's working because we've got 4 minuses and they're all cancelling out. So it's all just sort of, all I'm saying is if you've got a product of numbers, you need to know if it's greater than 0 or less than 0. All they want you to consider is sort of the signs of the number. And we'll see sort of examples of that going on. The other thing that you're going to be unsurprised at me saying is you want to solve a lot of inequality problems graphically. For example, if you see a question like when is 1 over x greater than x? Well, and we're going to talk about why I'm not going to just solve that in an easy way in terms of sort of multiplying in a second, but just sort of, if you can get away with not sort of messing around with it, because you can go wrong with inequality by messing around, well, we know how to sketch that. 1 over x is greater than x. Well, okay, 1 over x, x. When's 1 over x greater? Well, it looks to me like he's greater sort of in this region. So he's greater between 0 is less than x is less than 1. And when else is he greater? Well, it looks to me like he's greater in this region. So over there. Well, so minus 1 is less than, x is less than minus 1. That's it. So just a very quick example of why that can be helpful. When else is solving graphically important? X x squared minus 4. Let's see, x cubed minus 4x squared plus x. Well, simply factorize that. X, I want to actually pick something slightly nicer. I'm going to do this. Okay, x squared minus 2x plus 1 greater than 0. Factorize again, x minus 1 squared greater than 0, question mark. Well, we can sketch that thing out. Okay, I can plot that point at 0 and at 1. We know the 1 point is just sort of touching, so we know we have to sketch sort of like that. And then very quickly, when is that greater than 0? Well, it's greater than 0 as long as x is greater than 0, but also and x does not equal 1, because at 1 it's equal to 0, as we can see. So you can see sort of very quick ways of, graphs are just very helpful. They're quite easy to sketch, and most importantly, they make it very obvious that you're not going to miss solutions because you know what you're looking for. You're not going to miss this negative solution if you use a graphical method, which nicely brings us on to the next point. Never divide or multiply by something that could be negative. So, previous question, why did I say 1 over x is less than x? No, it's greater than x. Why didn't I just do this? Oh, I can't. There we go. why didn't I just do this? Surely then 1 is greater than x squared. And so what? I suppose using our rules, we'd say that x is less than 1, or x is greater than minus 1. That's using the rules we talked about earlier, except that's not what we got before. It's very similar, but have a look at it. That's not quite the same result. So why has that gone wrong? And just in case it's not clear, here we got the actual answer is x is less than minus 1, whereas here we've got x is greater than minus 1. So it has gone wrong. And the reason is because we don't know whether x is positive or negative. And when you multiply an inequality by a negative number, you have to flip the inequality sign. So we know that 7 is less than 9. Multiply both sides by minus 1. We have to say that minus 7 is greater than minus 9. So with numbers, it's nice and easy. But with letters like x, then, well, you really don't know whether to flip the inequality sign. So in other words, just don't do it. Effectively, never divide or multiply by x or y unless you know for sure it's positive or negative, because then you know what to do with it. So in this case, you could solve graphically in that way. But let's say it was something a bit more annoying. Let's say let's just use this example. Let's say in this form, you don't know how to sketch this graphically. Well, then how can you solve this algebraically or sort of get to another form? Well, instead of multiplying through by x, you have to multiply through by x squared on both sides. So that leads us to x is greater than x cubed. Now, that's actually fine because we know x squared is always positive. So as long as you multiply through by a positive, then you don't have to worry about flipping the inequality sign. And the solutions to this will be the same as the solutions to this. And so now we can just say, okay, well, you can just say that that means x cubed minus x is less than 0, x squared minus 1 is less than 0, x plus 1, x minus 1 is less than 0. And then again, I'm going to say, well, just to make sure we don't get this wrong, easiest way to do this, honestly, is just to sketch out the cubic, because then we can do this. And we're not going to miss any solutions, because when's that less than 0? Well, we can see it's between 0 is less than x is less than 1, and x is less than minus 1. And so then we get the same solution as earlier. So either way you want to do it, I really strongly recommend you use graphs when inequalities are involved. Now, all we've focused on so far are what I'd call sort of standard mathematical questions, all in sort of one variable. What the GMAT often likes to do is throw in sort of expressions like this. Is x minus y greater than z, for example, like that. And their graphs aren't really going to help you because unfortunately, and neither's algebra particularly, because unfortunately you can't really solve this or sketch it in terms of, what are you sketching in terms of? Before we're just sketching a function of x, whereas now we've got x, y, and z. So we're going to need a different method. And in general, as soon as you see these kind of questions, you sort of need to start thinking about number lines where you can sort of start ruling out sort of what various values each thing can take. So, for example, if we say if x greater than 3 and y less than 5 and z greater than 8, actually, let's say is xy greater than z. Okay, so effectively, when it I'll have a section on adding or subtracting inequalities. In general, I recommend against multiplying and dividing inequalities. There's lots of situations which you're not really able to do it, and it's not something that's tested particularly much in the GMAT, and you more just want to rely on sort of number lines and intuition for multiplying and division, just because inequalities get very sticky when you start doing that kind of thing. There's lots of ways in which you can go wrong. So instead, I'll just sort of say, okay, well, we know that x is greater than 3. So if I put 0 on here, I can say that 3 is there and x is that way. Y is less than 5. So, okay, we've got 5, and y is that everything that way. And the reason why I say I don't really like multiplying and dividing with inequalities is because, again, you have to worry about, is the thing positive or negative? And often you just don't know. So you're much better off just using this kind of thing and sort of staying away from doing that. And then we know z is greater than 8. Okay, so running out of colors here. Z is somewhere over here. Okay, and obviously this is just a question I've come up with. It's not particularly interesting or doesn't really make much sense, but effectively, is xy definitely greater than 8? Well, have a look at that. The answer is obviously no, because you can just you just mess around and try and come up with things. So if y is negative, then the answer is xy is negative. So there the answer would be no. But what if I say this instead? 3 is less than y is less than 5. Well, now all of a sudden, y can only be in, oh, I've lost the color, this region. And so then using the number line, you just sort of say to yourself, well, okay, is xy greater than z? Well, what's the smallest I can make xy? Well, I can make it 3 times 3, which is 9. So the worst case scenario, xy is 9, in which case xy is always greater than z. So that's just a guide on when you want to sort of start thinking about number lines. And we'll see a lot more of those examples in the example video. Okay, then we're getting near the end here of the sort of toolbox. I know there's a lot to know in this topic. Adding and subtracting inequalities. This is fine. Just be very careful about, and it actually can make some questions very easy, but just make sure you don't make silly errors. Effectively, signs have to agree. Now, that may sound like a limitation, but it's actually less of a limitation than you may think. X plus 2y is greater than 4. X minus y is less than 3. Okay, and then you know, is x greater than 0 ? Something like that. Well, okay, you may look at this and say, well, damn it, the signs don't agree, so we can't add them. Except there's nothing, and that's true, except there's nothing stopping you from just rewriting this one as well. If we just sort of bring the y and the x to the other side and flip, so therefore flip the sign, y minus x is greater than minus 3. We just sort of, you know, reversed everything. And now we are in a situation where we can sort of start adding and subtracting. So x plus 2y is greater than 4. Is x greater than 0? Well, all we want to do is know is get rid of y. So we can just sort of say, okay, subtract 2 of the bottom inequality from the top one. And so we get what? Well, x minus 2 sets of minus x, so that's going to be 3x. Then the y's have gone away, is greater than 4 minus 2 sets of minus 3, so 10. And so apparently x is greater than 10 over 3. So is x greater than 0? Yes, is the answer. Okay. So that's all I'd say about adding and subtracting inequalities. You can treat them as simultaneous equations, but just make sure the signs agree. But if they the GMAT loves doing this. They love making sure the signs don't agree in the form they give it to you. So just rearrange it so that the signs do agree. It's always going to be more, almost always going to be more helpful to have the signs agreeing, regardless of what you're going to be doing with inequalities. Okay, the next thing, square rooting inequalities. Well, very similar to moduluses and stuff like that. Obviously, if we have something like x squared equals 64, then we know that x equals plus or minus 8. Very similar thing applies to inequalities. X squared greater than 64, just like with moduluses, that means that x is greater than 8 or x is less than minus 8. And then cube rooting inequalities, actually not an issue, because so if x cubed is greater than 27, we know that x is simply greater than 3. And if x cubed is less than minus 8, then x is simply less than minus 2. So cube rooting, there's only going to be one solution. Now, squaring inequalities is when you really do want to be careful. Again, because what is squaring? If you think of it, squaring is kind of like multiplying inequality by itself. And if you remember what I said earlier, multiplying inequalities is something ideally you want to stay away from. So if we know that x is greater than 2, and basically all I can tell you here is just be very careful and just use some level of common sense. If x is greater than 2, well, then we know everything. If we square it, we know everything's positive, so we're fine. X squared is greater than 4. We're okay. But if x is less than 2, well, actually, now I'm in trouble, because can I square this? Well, if I square it, I get x squared is less than 4. But x could have been negative. And so if you think about, just think about it, x is less than 2. So x could be, for example, minus 10. What's minus 10 squared? Well, it's 100. And so clearly x squared doesn't have to be less than 4. So effectively, unfortunately, all I can say with inequalities is if you know everything's positive, go ahead, square, divide, multiply, do whatever you want. But if you don't know for sure something's not positive or negative, then you really just don't want to do it. There's no rules I can give you that are particularly helpful. So just be very careful of that kind of thing. Whereas luckily, cubing inequalities, just trying to think. No, cubing inequalities is always fine. Why is that? Well, if you think about it, what are you doing? If x is less than 2, how am I cubing that? Well, I'm multiplying both sides by itself twice. In other words, by itself squared. Effectively, the point being that it's always going to be positive, what you're multiplying it by. In other words, no matter what you do, you're going to get, it won't mess up the inequality. So cubing inequalities, you're fine. It's fine to do. Just squaring them, it's not always. And so with that said, we will see questions in the GMAT where it looks like that's sort of what they are getting at, but you'll see that my method for solving them is it's not simple. You have to just be very careful. Effectively, when you don't have much of a choice in terms of what you're able to do, you sort of have to default to number lines and just bear in mind, if you're not sure, just keep in mind that things could be positive or negative, and sort of just know what you can do and know what you can't do. And that was sort of the whole point of this video. And so now, with all of that horrible stuff out of the way, a lot of stuff, obviously, we can finally get onto our first examples video, where I'll go through a bunch of questions covering all of the material from the previous videos. And hopefully it should all be very clear that it's just using the stuff in this video, which isn't a huge amount. And hopefully you've picked something up from that.